everyone. In today's class, I'm going to provide solution to this given Olympiad question. Given that a to the power of b minus b raised to the power of a equals 17, then find the values of a and b. So when you look at this problem, we only have one equation, and the equation is a to the power of b minus b raised to the power of a equals 17. Okay, then from system of linear equations, simultaneous equations this time around, the number of equations equals number of unknown variables. So if you have two equations, you will have two unknown variables. If it is three equations, you definitely have three unknown variables. Even though we have other cases like that where the number of variables are more than the number of equations. But when you look at this one now, we have two unknown variables and one equation, and each of the term here is in terms of exponential. So what we're going to do here is just to rewrite this equation in terms of difference of 2 squared. You get that? And before we can proceed to that, you should note that when you have x, this can be written as 2x over 2. I'm sure you all know that, because of course these two will cancel this and you'll be left with x. So which implies that now for a to the power of b, that can actually be written as b divided by 2 raised to the power of 2. Okay, yeah, this is very simple. Let me just start with this times 2. Okay, and again for b raised to the power of a, that can be written as b raised to the power of a over 2 times 2 then equals 17. So this has nothing to do with the given problem, okay, because by the time these two cancel this, you eventually have the given equation. Okay, so now remember that when you have x to the power of m times n, this can be written as x to the power of n times m, and of course if you try to separate x to the power of n here, we can write m here now. So what are we trying to say is that you can just factorize 2 out, I mean the square. So by the time you do that, you're going to have b over 2, then in bracket 2, then minus the same thing applicable to this. You will have b raised to the power of a over 2, then your square is out now equals 17. Okay, you can see the left hand side of the equation is in terms of difference of 2 squared. Okay, so this is what we call difference of 2 squared. Whenever you have x squared minus y squared, this is difference of 2 squared. And of course we have formula for that, and what that means is that this can be written as x minus y, x plus y. Don't forget that. Okay, so by implication, okay, to make this equation simple now, so let's just say, okay, I think that would be better. Let's x equals a to the power of b over 2 and y be b raised to the power of a over 2. Okay, so at least that will reduce the equation. So in a place of a to the power of b over 2, now you put x, so you're going to have x squared minus, so in the place of b to the power of a over 2, you put y, so you have y squared here, then equals 17. Okay, and don't forget I told you what you have here can actually be written as x minus y, x plus y equals 17. So you can start with any of this, maybe x plus y or x minus y. So what this means is that the product of two factors equals 17. So product of two factors equals 17. So for us to get this, we need to get the factors of 17. Okay, so what are the factors of 17? So remember, 17 is a prime number. Okay, it's only divisible by itself and 1. So which implies that it has two factors, which are 1 and 17. So we have 1 times 17. This will give us 17. We can have minus 1 times minus 17 as well. This will give us 17. All right. So these are the possible numbers we can multiply together to obtain 17. All right. And now, so which of these are we going to use? Now let's start from here. Remember, we have value for x, which is in terms of a and b to be a to the power of b over 2. Then y is b to the power of a over 2. So it is not new to us that this result here, I'm talking about a to the power of b over 2, can never be negative, because just like you are taking the square roots of a raised to the power of b, that is what x means. Then for y, Y means you are taking square root of b raised to the power of a, and we all know that square root of any function, let me use p this time around, must be greater than or equals to 0. Okay, the result we're gonna get from this and this must be greater than or equals to 0, so must be what? Non-negative. You understand? So which implies that x and y are greater than 0. Okay, if x and y are greater than 0, now which one is greater between x and y now? So that's the next thing we need to check out. Okay, yeah, we have x squared minus y squared equals 17. So the difference of these two numbers equals 17. So for you to have 17 here, that implies that the value of x here is greater than y. That's the meaning. You understand what I'm saying? If x is less than y, that implies that you're gonna have negative results here. So by implication now, we can now write this as x is greater than y and y is greater than 0. You can see that now. So from here now, it is obvious that both x and y are positive numbers, are non-negative rather, because there is a difference between non-negative and positive. So let's just say non-positive, yeah, positive numbers. Okay, so by implication now, we're gonna make use of 1 and 17, so we can use this. Okay, so which implies that x minus y, x plus y can be written as 1 times 17. Okay, and it is obvious here that x plus y here, since x and y are positive numbers, so that means x plus y must be greater than what? X minus y. That's actually true. So which implies that by the time you now compare what you have at the left hand side with that of right hand side, you're gonna have x minus y to be 1 and x plus y equals 17. Do you get that now? So x minus 1 cannot be 17. Yes, it can only be 1 here. Y x plus y will be what? 17. Okay, now we have two equations now, so we can solve these two simultaneously. We can just take the sum of the equations. So we're gonna, by elimination method, we have x minus y plus x plus y equals 17, and of course this will take care of this, and you'll be left with x plus x, that's 2x. Don't forget you are going to have 17 plus 1 here, then you have 18. So to get x, what we do, divide both sides by 2, and you eventually have x to be what? 9. Now we've gotten value for x, then we use that to find y. So you can just put that in any of these equations we obtain here. So let me consider the first one here, which is x minus y equals 1. So by the time you put x to be 9 here, you have 9 minus y equals 1, and y equals that will be 9 minus 1. You get that? So which implies that y is equals to 8. So now we've gotten values for x and y now. X is 8 and y, x is 9 I mean, and y is 8. And don't forget, from the beginning, the equation, the problem is not in terms of x and y. So the problem is in terms of a and b, and that is what we need to find. Okay, so now recall that we have x from the beginning to be a to the power of b over 2. Y is a to the power of what? Y is what? B to the power of a over 2. So that's, let's recall from that. So x is a to the power of b over 2, and y is b to the power of a over 2. Okay, so let's make the substitution here. So that is a to the power of b over 2 now equals 9. I'm solving the two simultaneously, and the other side here you have b to the power of a over 2 equals 8. Yeah, for us to remove these two here, so we can just square both sides. A to the power of b over 2 all squared, then 9 squared. Same thing applicable to this. You have b to the power of a over 2 all squared equals 8 squared. And don't forget, this will take care of this, and you now be, you have a to the power of b, 9 squared is 81, and you have b to the power of a, 8 squared is what? 64. Okay, yeah, so the left hand side of each of the equations in terms of exponential, so we can do the same for the right hand side of the equations. Okay, so for a raised to the power of b, 81 can be written as 9 squared, but again that can also be written as 3 to the power of 4. And why this? B to the power of a, 64 can be written as 4 to the power of 3. Yeah, So now by comparing what you have here now, that means B here is 4, A is 3. A is 3 here, B is 4. Can you see that now? So which implies that the value of A is 3 and B is what? 4. And that satisfies for the two equations we obtained here. Alright, so for you to confirm the answer, you can actually make substitution for the values of A and B in the given question to check whether you get 17 or you get contrary value to that. Alright, so don't forget to like, drop your comments and subscribe. Thank you.